right, well, let's get rolling here. Welcome to an overview of Windows Azure. My name is Bret Stateham. I'm a Microsoft technical evangelist for Microsoft. I'm actually based here in San Diego and cover all of SoCal. The downloads here are going to be where you can go download the SDK. So if we're doing .NET development in here, I have SDKs for Visual Studio 2012 and Visual Studio 2010 that install not only all of the command line tools that you need to build Azure applications on your box, but also great tight integration into the Visual Studio environment that lets you write from in VS, do step-through debugging of your cloud services, pushing them up into Azure, lots of other cool stuff there. So you can go get all of that stuff from there. The other thing that we have then is the management portal. So up here in the top right-hand corner, if I go to portal, and I'm already signed in with my live ID, so it's automatically taking me in, but you'd sign in with the live ID that's associated with your account, and I can see from here that I have the ability to manage all of my Azure-related resources. So I talked about virtual machines and cloud services, websites. We also have Azure SQL, Windows Azure mobile services, storage services, virtual networking, SQL reporting services, service bus. I mean, a ton of cool functionality. All right here in a very nice, easy to use management portal. This actually used to be Silverlight based. It's now just HTML. So you can pretty much call this or call into this from any browser and have a go at it. So that's pretty cool. So I mentioned that for me, I'm a big proponent of cloud services. I really think cloud services are the way that we ought to be thinking about building applications, right, as we move forward, or just in general platform as a service, right? And of course, I'd love that to be on Azure, but just even as you consider going across cloud vendors, there's a ton of platforms as a service offerings out there, and I think it's great because, again, it gives you a lot more flexibility in how and when your code runs. But basically, the idea here is that in Visual Studio, I'm going to go in and write some code, and I'm going to package that code up in a format that Azure's data center knows what to do with it, right? So I'm going to go out and I'm going to write maybe a website and maybe some worker roles, and so I'm going to get this collection of DLLs and content files and all that kind of stuff. Along with that, I also need to tell Azure how many copies of that web server do I want, or how many copies of that back-end processing service do I want. Do I have networking endpoints that I need to expose so I can talk to them from the outside world, and what are those endpoints, and what are the ports, and all that good stuff, right? So if you think about all the things that you might have to do on premise to deploy an in-house application, that's a lot of the same information that we need to bundle up into this package. And we ship that package up to the data center, and it's effectively a zip file that has all that stuff in it. It's going to extract that zip file and look at it and go, oh, okay, hey, we need 3 virtual machines for the web front end. We need 2 VMs to run these worker roles on the back end. Here's the code for the web. Here's the code for the worker role. Spin the VMs up. Now, those VMs are Windows Server VMs, right? They're Windows virtual machines. They're just built and managed by the Azure Data Center. Not only that, they're automatically service packed and hotfixed and all that kind of stuff by the Azure Data Center staff, right? So you're not having to go in and take care of that stuff. And as those updates occur, they'll roll them through your running VMs and keep your VMs up to date with the latest security patches and all that good stuff, right? So it goes out, figures out what VMs it needs, pulls the images, chooses from all the different virtual machines that are out there, where available, where it wants to run your code, and then basically goes out and spins that stuff up, right? So it's going to go look across the data center, find all the physical boxes that have room for the virtual machines you're requesting, and basically go out and allocate those virtual machines, right? So now somewhere in our data center, you've got some VMs running with your, or that will be available for your code. It's then going to go out and basically deploy your code down to those virtual machines, pardon me, and then set up a network load balancer. So you get this load balance workload provided to you, and now exposes the public endpoints, and I can have clients out there in the world then come in and connect with this, right? So that can all happen through what we call deployment. I've got my network load balancer in place. Everything's chugging along great. If I had maybe a failure of my web front end or something like that, if it crashed, the Azure Data Center has in it a special piece of software called the Fabric Controller, and it's basically going to discover this crashed VM. It already knows what the VM was. It already knows what code was on it. It's going to go, oh, hey, let's just shut that VM down, go spin a new one up, and then just redirect the load balancer off to that new virtual machine. Right? And that's going to happen transparent to you. You don't have to do anything about that. Now, if the one that went down was the only virtual machine that was running your website, while that recovery happened, your website was down. Right? So you want to make sure that as you're deploying cloud services and that kind of stuff, if you expect that 99.95% SLA, you have to have at least 2 copies of every role. Right? You have to have 2 copies of your web front end, 2 copies of your worker roles, whatever those are, so that should one crash, there's another one already running that the load balancer can direct all that traffic off to. So let me jump back over here and talk about cloud services. Spin up Studio here. So I'm going to use Visual Studio 2012 here, and I've already installed the SDKs and the client project, or the Visual Studio tools and all that good stuff, right? So this is all set to go. And so from my file menu, when I come down to New and Project, you'll notice that under the language of your choice, once these have been installed, there should be a Cloud category, and I have this Windows Azure Cloud Service. So this is the platform as a service model that we were talking about. And so a cloud service could have multiple what we call roles running in it. So I'll walk through that here in a second. The service itself is really just sort of an umbrella over that. So I'm going to go back here and I've got a demo folder I want to run this in. All right, and so I'm going to call this guy Cloud Shop. So the idea here is that I want to build like maybe a web store or a store up in the internet, right? That folks can come to a web page, place an order, and then I'll have some background processing that deals with processing the orders for it, right? So as I create this cloud service, it says, well, what are the different roles that you want to create inside this cloud service? And a role is really sort of 2 things. One, it's the definition of the virtual machine that you want to have your code run on. And then it's also, what is the code? What are you going to run on that virtual machine? And so I have a bunch of different roles that are available here. You'll notice that I have some web roles. And a web role basically specifies a virtual machine. So it's going to be a Windows Server box that has IIS pre-installed. There you go, right? And then what you're going to do is deploy into that IIS environment the code that you'd like to have run on it, right? So usually that's going to be ASP.NET, but you can run PHP and other things like that on IIS if you want to. It's going to require a little more custom configuration than what the Visual Studio project templates make readily available, right? So remember, what we're seeing here right now is how Visual Studio makes life easy for a .NET dev. This isn't the only way to build these, though, right? So you can build cloud projects and things like that even from the command line if you want to. But there's tons of documentation on doing PHP or other web front ends, etc., up in your cloud services. All right, so I'm going to have just a regular old ASP.NET web role, but notice I have project templates out there as well for MVC, for WCF services as well. So I'm going to add a web role over. And what I'm really defining now is a new project in Visual Studio for an ASP.NET web role. And I get to name that project, and I'm going to call it my Cloud Shop Web Role. Now, notice there's also worker role projects down here, and a worker role defines a virtual machine. It's a Windows Server VM. It just doesn't have IIS. Right? So it's just a Windows Server box. So that's really the key difference. Web roles, VMs have IIS. Worker roles are VMs that don't have IIS. Okay? So worker roles are great for the types of workloads that you might run on premise that aren't web-based, right? Back-end processing, or any, like if you think of a Windows service that you might run on-house or in-house, a worker role might be a sort of a cloud alternative to that. The worker roles also are ways that you could build maybe your own web platform. What if you say, I want to run Apache, I don't want IIS? So the web role might not be the right story for that. Say, why don't you just give me a worker role, and in the package that I deploy up into the data center, I'm going to include either the Apache install media or a script that can go download the Apache install media and install it on that box, right? And then install PHP. Now that means that the startup time for that VM is going to be a little bit longer because it's got to spin the VM up, and then it's got to install all this stuff, and then deploy your code into it, and then run that code. Does that make sense? And if that VM goes down, it's going to have to get a fresh copy and re-go through all that setup configuration. Because with Platform as a Service, these virtual machines that we use are stateless. That means that once they go down, when they come back up, they're clean, right? We have to redeploy the code to it. And so that's definitely something that as a developer we have to think about, right? We can't expect that that computer is going to reboot and that we're going to have, if I wrote something to the C drive, it's not going to be there, right? So we want to make sure that we're persisting our data off over into either Azure SQL databases or off into our tables or blob storage or something like that, and getting it out of the VM. And I'll talk through that. We'll do a demo of doing that. So I'm going to go ahead and create this guy with just a web role. I don't want to have a worker role right now. I'm going to go ahead and say OK. All right, and if I look at my Solution Explorer over here, even though this was a quote-unquote web role, it's just a regular ASP.NET website, right? There's nothing different about this. In fact, I could have gone in and just made a regular ASP.NET website and then sort of backed it in to a cloud services if I wanted to. But this project that you see right here is exactly the same project if you were to have just gone in and said File, New Project, and under Web said, hey, just give me an ASP.NET Web Forms application. That's what you would have gotten. It's the same project structure over here with a few differences. Under the references, you'll notice that there's references off to some Windows Azure libraries, right? So remember I mentioned there's this client SDK for .NET, and all the services that are available up in Azure are manageable through a RESTful API. But they're also callable through a .NET object model up inside the runtime. Now, some of them only make sense inside Azure. Other ones make sense outside and inside, right? Depending on where you're coming from. But I have the configuration API, helps me configure my services that are running. I have a diagnostics API that I can use for both reporting and consuming diagnostics data. We have the service runtime that says when my code is running in Azure, it can discover the environment that it's running in. Tell me, how many other copies of my role are there? What's my role ID? What are the endpoints on all the other roles so I can go communicate with them and all that kind of stuff? The Service Runtime API helps me do that. And then the Storage Client API helps me work with tables, queues, and blobs that are available out there as well. And we'll see that Storage Client coming up here in the demo. All right. So those references are in place. The only other real difference that you're going to see here is that there's another class that got added into the project called webrole.cs. So that is the class that, in fact, if I open it up and look at the code, I see that it inherits from role entry point, and role entry point is included in that service runtime API, in that service runtime library. And so basically the role entry point is a class that my project's going to expose that the runtime can call into when Azure goes and starts my code up and says, hey, I need to sort of bootstrap you and be able to work with you. You'll notice that there's basically an onStart method that I can run. Say when the runtime is starting me up, it can say, hey, by the way, I'm starting you. If there's anything you want to do at startup, here's where you can go write that code. Now there's other overrides that I could use here as well. You'll notice I have on stop and then run. And now you'll notice that this base class, or the one that was included, doesn't implement run or on stop. And that's because this is a web role, and the web role already knows how to run its code. I don't have to go tell it what to do. In a worker role, though, run is the whole point. Here's what I want you to do. So when we come back into a worker role, we'll see the run method get implemented. All right. So I'm going to leave that as is. Now, if this were a normal ASP.NET web application, when I came in and debug, it would use either the Visual Studio 2012 development server, or it would use IIS Express. In this case, it's actually going to go spin up for me the Windows Azure Compute and Storage emulator. And the Compute emulator is going to help me simulate the fabric that would actually be used up inside the Azure Data Center. So right now, if I come down to my system tray and click in here, in the pop-up there, there's no icon that looks like a Windows logo. We'll see it in a minute. I just want to show you that right now it's not there. And then we'll see it when we do come run this. So I'm just going to hit debug just like I normally would. But we should see some messages pop up that tells me that it's starting the storage emulator and the compute emulator. So it's spinning those out. Now those things are included in the SDK. And so that got installed when I installed the SDK. And Visual Studio knows how to start them up and deploy my code into them when I use it from Visual Studio. So that's part of the Visual Studio tools. And down here in the system tray, I now see this icon that looks like a little Windows logo. And that's sort of my little interface to look at the compute and storage emulators here. So I'm going to right click on this and say show me the compute emulator UI. And I see that I have a deployment into this compute emulator UI. There's the Cloud Shop service. Remember, that's what I called my cloud service. And inside the cloud service, I had a single web role called Cloud Shop Web Role. And I have one instance of my web role running right now. And there it is. Now, the console window that you're seeing here looks kind of like a command prompt. It's not. It's just that diagnostics log that's being shown to you. That's popping up in the screen there. But it gives me a way to monitor what's going on inside that web role. If I come back to my browser, there's the page that's running. You might notice that the port looks a little different. Usually the dev server is listening on some random, 57,294 port or something like that. This one's almost port 80. It just couldn't use port 80 because I'm already using port 80 on this box. So the compute emulator goes, let's just use the next port, and it went up to 81, right? But otherwise, it's just pointing at my local computer, port 81, and there it is, and that's my regular website. Now, usually when you work with Visual Studio, if you're debugging the web app, when you close the browser, the debugger shuts down for you, and we can watch this. Notice that role state destroyed, and it undeployed my web role for me. This is awesome, right? So I get to debug these guys just like I would regular projects, but they're running inside the compute emulator. You can create breakpoints and step through and all the things that you're used to doing with regular web projects. All right. So there's my cloud service. Now right now it's all running down here on my workstation inside the compute emulator. If I wanted to, though, I could come up into Azure and under cloud services, I could create a new cloud service and deploy my code up into it, right? So in fact, if I were to go into a cloud, let's go back to a different one here. Notice that I could upload a package here, right? So I could go somehow create a package, and the SDK has command line tools that'll help you do all that stuff. You could create it however you want, basically upload this package into the Azure environment there for it. But I am instead going to do that from Studio. So I can come back over here and right-click on my Cloud Shop cloud service, and you'll notice that I have this option right here to just publish this. Now, Visual Studio needs to know how to sign into my Azure account. And because I dev on this box all the time, I see that it already recognizes this AZDem, Azure Demo subscription that I already have out here. So I'm going to go ahead and use that subscription, but you can always go create new credentials here if you want to. And one of the ways that you can do that is to sign in to download credentials. And this will log you in to the Azure Management Portal and give you a way to download. So it's going to download this published settings file. You'd save that down to your local workstation. And what that's going to have is the certificate information that's needed for you to manage this. Then once I have saved the published settings down locally, then back over here, I can click the import button and go point off to that published settings file, wherever I saved it. And that'll pull it in and give me a way to, from Visual Studio, nicely interact with my Azure service. Okay, so I just went through those steps. I already have it in place, so here's the subscription I want to use. So I'll move on to next. It says, okay, we see that you already have some cloud services in place. Do you want to just deploy this code up into the existing cloud service, or do you want to create a new cloud service? I'm going to say, let me create a new one here. And what are we going to call it? We'll call it Cloud Shop. And this comes back to the, where are you going to put your code? All right, remember I said there's 8 data centers worldwide. So here it's asking you, which data center do you want this code to run in? Now, so I'm out in the West, US, so I'll pick West US. But you could pick the data center that was more appropriate for you and go ahead and say, okay. And so it's actually going up and specified DNS name's already taken, so I can't use Cloud Shop. So I'm going to go make one that's a little bit uglier. We'll stick today's date on it. There we go. I doubt anybody has that as their cloud service name, so I'll say okay. Now I care about this because that's going to be the host name and my DNS name. So my fully qualified DNS names now going to be CloudShop 130315.cloudapp.net, and that's going to be the URL. Now you can put your own nice, www.mycompany.com on that, but we don't host DNS. You'll have to go off and configure your own DNS, create a CNAME record that points off to this ugly name, and sort of map users over that way. But I'll go and say, okay, that time that should be an unused name. All right, that looks good. And it says, okay, now where do you want to deploy this code? You want to deploy it into production? Or we also have a staging environment. Every cloud service actually has sort of 2 containers that you can deploy code into. The production one is the one that listens on that name, Cloud Shop 1305 or 130315. There we go. Thanks. I'll get it right sometime. And so that's going to be, production is the one that responds when you go to that host name. Staging, you get a GUID-based host name. That's a way for you to sort of deploy code, but nobody would ever know the URL. And it gives you a way to sort of test it, see if it works. And then when you're ready, you can do what we call a VIP swap, where you basically take the production host name and point it at that container, and boom, your staged code is now production, and your production code is now staged. It just swaps them, right? I want to go straight to production, though, because I believe it's going to work. It says, okay, well, we're going to go build your project for you. Do you want to build with debug, or do you want to build with the release configuration? I'll have it use release. And we'll talk about cloud configuration here. But remember, I mentioned that when you deploy it, there's going to be some metadata or things that you describe about how many copies of each role do you want, etc. And so there's configuration files that we have locally, and it's asking you which one of them do you want to use. And I'll say you use the cloud version of this. Now remember, I said the roles that you produce are really Windows virtual machines. And so there's a checkbox down here, let me go back on that says if you would like to, you can actually remote desktop into those VMs. If you want to enable that, you can. It says we just need to know a username to create for you. So I'll go ahead and call this B. Stateham for my name. Put a password in here. All right. And I'll leave that all as is and say OK. But now I can actually remote into those with my username and password. Now remember, I said those virtual machines are stateless. So you don't want to remote in and do any configuration, because if those VMs get reset, any configuration you did is going to be gone, right? But you can remote in for monitoring or to figure out what's going on inside this virtual machine, right? To look at the event logs or look at the performance counter or something like that if you want to. You can do that. I'll just move on to next here, though, and that looks good to me. I'm going to publish this up. So, here's my, there we go. It was taking time to come up here. This Windows Azure activity log window should appear. And basically, it's going to keep an eye on this deployment process for me. And it's telling me that we started this back at 10:56 a.m., and it's going to start deploying this project up into the Azure data centers for me. So it's built the package. It's going in and through the management APIs, configured all those services and all that stuff for me. And then it's going to deploy that package up, but then it has to still go pull the VMs over, start them up, deploy my code into them, get them running. So it takes a few minutes for that all to happen. But it's really not that bad. And remember that these virtual machines didn't exist when I started this. So it's really pretty amazing that I can provision a VM somewhere in the data center, I don't even know where it's at, deploy my code into it and have it running, in under 10 minutes. Most on-premise shops couldn't do that for you. So we make that pretty easy to go through there. So yeah, question. The System Center actually has a fair amount of stuff built into it for Azure, although I have not used the tools myself, so I wouldn't be the best resource for you. But yeah, definitely there's some a lot of integration that's gone into System Center with Azure, and there will continue to be more. But that's my brochure answer for you. I'd be happy to point you off to either Chris Avis or another IT pro that could talk through that with you. All right, so let's see how this is going here. Did it finish up? Ooh, it says it's done. So notice here that it shows me the website URL. It can't be done yet. No, it's still deploying. It's getting there. And I can actually monitor the status of it down here. All role instances have stopped. Starting up, instance 0, it's creating the virtual machine, so it's sort of stepping through this process here as it goes and builds this. Starting up the VM for me. So what I'm creating up in Azure right now are two things. There's the cloud service, but then into that cloud service, I'm deploying an instance of my application, right? And so tomorrow I might decide, I have to fix it. And then I'm going to redeploy. And that's going to be a new deployment. So your deployment gets a name or an ID. In this case, it's got some funky long sequence of characters out there, right? But you might want to set deployment names and IDs that are time and date stamped, or maybe include the version information or whatever out there. But you can certainly do new deployments in the future here.
Bret, can I ask you a question?
Yeah, please. Question.
So we set up this VM on the fly. It didn't ask anything about memory or processing power or anything like that.
Yeah. So it didn't ask, but I was telling it. And we haven't talked about these configuration files. We'll be coming back in here and looking at these. But if I go to my role here inside the Cloud Shop project, I see this node here that says Cloud Shop Web Role. But notice I have a project down below called Cloud Shop Web Role. So this is the actual code, whereas this is the configuration of where that code is going to run. All right. Now the configuration is actually kept in these files down here, but this little icon here gives me a graphical way to edit this configuration. So I'm just going to double click on that, and you'll notice that I get this property sheet that pops up. And going back to your question, you'll notice that I've told it I want one copy of the virtual machine for my web role, and that virtual machine is going to be a small VM. And that's kind of how we classify them. And you can go back in here and learn about your VM sizes. And I see that a small gives me one core, 1.75 gigabytes of memory, and then a certain amount of local storage disk space and allowed bandwidth. Right, and so it's these different VM classifications that you choose from.
You have to pick one of those.
Yep, one of those. Yep. So, and the pricing is going to vary with these. I think with extra small, we're all the way down to like 4 cents an hour or something like that. Last time I checked, and extra large is up to 96 cents an hour. So pretty significant, difference in pricing between those two. All right, so back over here in Studio, let's go back and check on this guy. It's still chugging away here. We're getting closer. So we got the VM there. Now notice I'm monitoring this all down here from Visual Studio. I could also jump back up into the management portal and go into the dashboard on that. And it lets me know that not all role instances are ready yet, that it's chugging away, getting close. And so I can sort of keep an eye on it from the portal up here as well as I want to. So hopefully this will finish up in the next minute or two so we can show you this. All right, complete. Look at that. It's almost like I knew it was going to happen then. Cool. So that URL, notice, is now that funky name I came up with, CloudShop 130315, .cloudapp.net. So your cloud service names are always going to be your cloud service name .cloudapp.net. Now, if you want a different name, you go into your DNS, you configure a CNAME that points off to this name. All right? But I can now click on that URL, and it's going to go pull it up in my browser for me. And this is an ASP.NET app, so the first time it's going to go through its little just-in-time build and all that good stuff. But there it is. There's my web app now deployed up into the cloud. Pretty cool? All right. So those are cloud services. Now, granted, I had a single VM. I just had a basic web app. But at least we saw the full cycle of going in, building a cloud service, getting one or more roles into it, getting the code packaged up, published up into the cloud, and now I have this running service up in the cloud at this point. I am now also being billed for it, right? So I do want to be aware of that. This is an Azure VM. It's the small one, and I won't quote the pricing here, but while this guy is deployed, I'm being charged for that. So if I were to not want to be charged for this guy anymore, I'm going to want to come back here and first of all stop my cloud service, all right? And that's going to shut down all of the roles and all of the VMs for those roles and get them all shut down here for me. And that's going to take a little bit of time. When it's done though, oh actually, is it already done? No, it's not done, sorry. Not paying attention. So it's being stopped. Eventually it's going to stop. And then I'm going to want to come in and delete my deployment that's in there. And once you delete the deployment, that's going to keep you from being billed for that. The deployment is going to cost you, though, because it's consuming storage and it's consuming virtual computing resources. Even if those CPUs aren't running, they're still allocated. And so we're going to bill you for them if they're still allocated. So
Bret, I'm sorry. So this URL was published, but it wasn't. It was published to who?
Well, the Azure Data Center.
Right, but I mean the actual URL wasn't. There's no DNS for that. URL.
Well, we host our own DNS for our names. So that cloudapp.net, that's our zone. We host the DNS for that zone.
Okay.
But I'm saying we're not going to host jackinthebox.com, right? It's going to be cloudapp.net is the zone that we maintain.
I just tried to log into that site before you turned it off, and it didn't connect. Should I?
Yeah, it should have worked for you, and I'd be happy to look at it with you afterwards. But yeah, no, it's out there in the world. That's a globally available URL at that point, right? But then I'm going to want to come back in, as I say, and delete that so that I'm no longer being billed for that. I'm going to leave it in place. We can come back and start it up later on if I want to. But just be aware that while you still have them deployed, you're going to be billed. And I'm not trying to scare you off, but I want to be honest about it and make sure that you realize that if you're playing around, especially as a dev, and you go create some services, and then you shut them down, you're still being billed for those cloud services if there's a deployment in them. So, all right. So those are cloud services. And I mentioned that a big part of cloud services is this stateless idea, that those VMs get spun up off of a base image, and if for any reason they have to be cycled, Azure's not going to attempt to go in and recover your data out of that VM. The only thing Azure really knows about you is that service package that you sent up, which is your configuration and your code. And they're going to maintain that configuration, and they're going to deploy your code for you. So if a VM goes down, they just discard it. They get a fresh copy of it, spin it up, and redeploy your code, right? So your code has to be written stateless. That means that you can't expect the machine that you're running on to have the same thing it had on it 5 minutes ago in terms of memory or anything like that, or storage. So you want to keep your data off somewhere else. And we have some abstractions to help you with that. We have Azure Storage, or we also have Azure SQL, which is another place that you can do that. With that said, we'll come back in here and talk about Azure Storage.